Hello everyone, thank you for joining DIGITIMES Asia EV webinar. I'm Rebecca Wu, your MC today. In today's session, we'll be discovering the global innovation opportunities, find out how to build an all-round EV ecosystem, strategizing for EV blue ocean. We're also very pleased to have two well-known enterprises joining us in today's session. The first one is Chroma ATE, a world-leading supplier of precision test and measurement instrumentation, automated test systems, intelligence manufacturing systems, and test and automation turnkey solutions. With continuous leading technology and integration capabilities in optics, mechanics, electronics, thermal control, and software, Chroma gains its competitive advantages and drives future growth. Before we start, I'd like to remind that if you have any questions, feel free to leave your message in the chat room on the right side. Our speakers and experts will help to answer during or after the session. We also encourage you to share your thoughts or give recognition to the speakers, since your support is our biggest motivation. Now we'd like to introduce our first session speaker, Chang. As the product manager of T&M BU at Chroma ATE, Mr. Chang is responsible for the product planning and launch of new battery cell testing and software test solutions. He'll be introducing lithium-ion battery reliability testing technology and its challenges. Now let's welcome Mr. Chang.
Hello everyone, I'm Chang. Welcome to join the DIGITIMES webinar. I'm a product manager of the battery cell reliability test solution from Chroma. First of all, I would like to thank DIGITIMES for giving me an opportunity to participate in this webinar. Today, the topic we will talk a lot is battery reliability testing technology and its challenges. There are 4 parts to the agenda for this webinar. First, we will talk about why to test batteries. Next, based on Chroma's point of view, I will explain why EV batteries need peak power capability testing, why EV batteries need ripple current testing, and how to realize in situ analysis and accelerate the identification of the agent mechanism of the battery and their testing challenges. Then I will introduce the Chroma solution and its features. Finally, I will give a summary of the above. Why to test the batteries? The cost of the lithium battery pack has dropped from the $1,200 per kilowatt in 2008 to $157 per kilowatt in 2021, a drop as much as 87%. And research reports from the various parties generally believe the cost should be reduced to the level of the $100 per kilowatt, even with the rapid development of the battery technology. From the perspective of the cost structure of electric vehicles, the most important components in the battery pack is the battery cell, which accounts for about 50 to 60% of the cost of battery pack. Therefore, the availability of the battery pack is very important. At the same time, the battery is a key factor in determining the many performance indicators of an electric vehicle. For example, the driving range of an electric vehicle is determined by the energy stored in the battery, and the charge time is determined by the current rate capability of the battery. The acceleration performance of electric vehicles is provided by power of the battery. In addition, the agent of the battery will direct effect to overall performance and durability of the electric vehicle. Battery is a complex energy storage system. When battery is operated under the different conditions, a variety side reaction will occur inside the battery and lead to the different battery agent model. For example, when the battery is operated at a high temperature for a long time, the SEI will grow and decompose rapidly, resulting in a rapid loss of the lithium in the battery and increase in the internal resistance. What direct impact do these electric effects have on EV performance? As battery capacity declines, the energy stored in the battery decreases, resulting in a shorter driving range. When internal resistance of the battery increases, the available power of the battery will decrease, resulting in decreased vehicle performance. In conclusion, in order to ensure the performance and the durability of electric vehicles, it is critical to verify the performance and reliability of the battery. Next, let's talk about the test challenge that the development of the electric vehicle will bring. Why EV battery need peak power capability testing? In practical EV application, it is necessary to determine the power available from the battery to meet EV acceleration, regenerative braking, and the hill climbing power requirements to avoid the battery being operated outside the safe range. Therefore, before designing the power state estimation algorithm of the BMS, a larger amount of test data is needed to evaluate the battery power capability and temperature rise. The purpose of the test focuses on the calculation of the charge and discharge power capability and estimated battery temperature rise. The test standard is mainly based on the test method recommended by Freedom Car, as known as HPPC test method. First, the battery was discharged to the specified SOC at C/3 current rate. Next, it was left to the rest for 1 hour under the open circuit voltage condition. And then the discharge current pulse was performed for the 30 seconds through the measure current, voltage, DC internal resistance, and temperature data. The power capability and temperature rise rate of battery can be identified. In recent years, LFP cost advantage become increased prominent over the 2016 to 2022 as China gradually phased out the EV subsidies, which was in favor of the high energy density NCM battery in order to improve the energy density of battery pack. High capacity LFP battery have become the mainstream of the development in the next generation low-cost electric vehicle. Below are main reasons why LFP batteries are better alternative to the ternary batteries. First, low cost. Second, small environment impact. Third, improve the efficiency and performance. Fourth, enhance stability and safety. With the development trend, high-capacity LFP batteries, what challenge will we face? First of all, the power of the charge and discharge equipment of testing the peak power is also increased accordingly. For example, a battery with a capacity 300 amp-hour will have a current pulse up to the 900 amp at a 3C rate. High power equipment means more energy consumption and increased investment cost. This means we need more energy efficient and low-cost test solutions. Next, let's talk about why EV battery need ripple current testing. The powertrain architecture and electric vehicle consists of power electronic components and motors to manage the energy flow between the different powertrain subsystems and transmit the torque and power to the wheels. This power subsystem generate undesirable electrical harmonic on the DC bus of the powertrain. This may cause a vehicle battery to be subject to the DC and superimpose undesirable high frequency and low frequency AC. That is ripple. Actual measurements demonstrate the obvious ripple current disturbance in the range of 50 Hz to 4 kHz on the high voltage DC bus of the EV. When the battery is about fully charged, the impact of ripple current may cause the battery to be overcharged temporarily. However, present the BMS protection mechanism range between 1 millisecond to 10 milliseconds cannot achieve the battery protection through the timing blocking the BMS protection circuit unit from the transient overcharge at a ripple frequency of 100 Hz to 1 kHz and above. In a low temperature environment, the internal resistance of a battery will increase several times to enlarge the impact of ripple current on it. The purpose of the test is to verify the degradation rate of the battery capacity under the ripple current impact condition, and whether the lithium deposition occurs due to the overcharge caused by the ripple current during the CV charge stage. Regarding the ripple current testing, it's a pity that there is currently no internal test standard. Therefore, test specifications are mostly defined by vehicle manufacturers. The main challenge of the ripple current testing. First, there is no international standard for the lithium battery ripple testing. Second, the cell manufacturer only guarantees that the absolute upper limit voltage is the specification. Third, silent AC ripple in the EVs cannot be completely eliminated. OEM must verify the ripple current does not cause exacerbated battery degradation and lithium deposition. Here are Chroma's recommendations. First, the test temperature should be based on the low temperature field because the internal resistance of the battery increases under the low temperature condition and impact the ripple current will be more intense. Second, regarding the test current amplitude waveform, we recommend using the larger AC current to shorten the test time and using a sine wave to reduce unnecessary experimental difference. Third, the test frequency is mainly between 100 Hz to 20 kHz. Next, let's talk about how to implement the in-situ analysis to accelerate the identification of the battery agent mechanism. A general battery degradation analysis method is to disassemble the battery and manufacture it into the positive and negative half cells to evaluate the capacity degradation rate. This method has several disadvantages. Disassembling the battery will cause the change in the structure and stress of battery. The removal of the positive and the negative electrodes from the cross systems, the physical properties of active material surface may change, and the electrolyte and separate are different from the prototype battery. This difference may cause the deterioration analysis errors. To overcome the risk disassembly, it is important to use in-situ analysis of battery degradation. Therefore, in-situ analysis methods have attracted much attention in recent years. The voltage difference method is one of the high precision in-situ analysis methods. By defining the characteristic peaks and distance of the DVDQ curve through the knowledge of the experts, the capacity degradation rate of the positive and negative electrodes can be calculated correctly. And lithium loss of the battery can also be estimated. However, the challenge is that the characteristic peaks cannot be clearly identified due to the poor precision specification of the general charge-discharge equipment. Therefore, additional data smoothing operations are required, which may distort the DVDQ data and consume a lot of analysis resources. Next, let's talk about the Chroma solutions. Chroma has released the solution 7010H for pulse current testing this year. This device has twice of the output current in 30 seconds and can be effectively applied in the HPPC testing. Its maximum pulse current output is as high as 4,800 amps, which can handle with all electric vehicle batteries on the market. It also had high voltage and current measurement accuracy, which can improve the accuracy of power capability estimation. During the test discharge process, energy can also be recovered to the power grid, which can achieve energy saving and low heat generation. Regarding the ripple current test solution, Chroma has launched the ripple current test system 7010 based on the requirement of the EV manufacturer specification. Its electrical specification not only meet the test specification of OEMs, but also provide a wider frequency range and high current amplitude output capability to help customers shorten the test time. For ultra-high precision measurement solutions, Chroma will release the 7020AM-5-12C charge and discharge equipment with 20 ppm precision specification. At the end of year, it can provide ultra-high precision voltage and capacity measurement capability to help customers accurately and efficiently perform in-situ battery degradation analysis. Finally, the summary is as follows. Batteries are an essential part of EVs, have a strong impact on EV cost and performance, and are complex and difficult to master. Battery pack development requires more cell testing, include the peak power capability testing, ripple current testing, and ultra-high precision in-situ analysis to identify battery aging mechanisms. Chroma battery cell test solution has high pulse current output capability, energy recovery function, wider frequency range, and high amplitude ripple current output capability, and ultra-high precision measurement technology. Welcome to contact us if you want to know more about our solution. Thank you for listening. Bye-bye.
And that's all the sessions of the day. Thank you all for your participation. I'd like to remind all of you that don't forget to fill in the feedback form since your opinion is highly valued. Once again, thank you all for your time today. I'm your MC, Rebecca. See you next time.